Water scarcity is a pressing global issue. Around the world, communities are grappling with the challenge of ensuring a reliable supply of clean water. From parched landscapes to dwindling reservoirs, the signs of water stress are everywhere. Many regions face water stress due to climate change, population growth, and pollution. Urban areas are particularly hard hit, with growing populations putting immense pressure on existing water resources. Rivers and lakes that once teemed with life are now struggling under the weight of pollution and overuse. Desalination, the process of removing salt from seawater to produce fresh water, offers a potential solution. This technology has advanced significantly over the years, making it more efficient and accessible. Modern desalination plants use sophisticated methods to ensure that the water produced is safe and clean for consumption. It's like turning the vast, salty oceans into giant reservoirs of drinking water. The oceans, which cover more than 70% of the Earth's surface, hold an almost limitless supply of water. By harnessing this resource, we can alleviate the pressure on fresh water sources and provide a sustainable solution to water scarcity. This technology is particularly important for arid regions with limited freshwater sources. Countries like Saudi Arabia, Israel, and the United Arab Emirates have invested heavily in desalination to secure their water future. These nations, located in some of the driest parts of the world, have become leaders in desalination technology, and Singapore already rely heavily on desalination to meet their water demands. In these urban centers, desalination plants are a critical part of the water infrastructure, ensuring that residents have access to clean, safe water every day. As water scarcity intensifies worldwide, desalination is likely to play an even more crucial role in the future. With ongoing advancements in technology, desalination could become more cost-effective and environmentally friendly, making it a viable option for more regions. By investing in desalination, we can help ensure a sustainable water future for generations to come. There are two main methods of desalination: reverse osmosis and thermal desalination. Each method has its own advantages and disadvantages in terms of energy consumption, cost, and environmental impact. Understanding these differences is crucial for choosing the most appropriate desalination technology for a specific location and its unique needs. Reverse osmosis is like a microscopic sieve that separates salt from water. Imagine a filter so fine that it can trap salt molecules while allowing water molecules to pass through. This process requires high pressure to force the water through the membrane, leaving the salt behind. Reverse osmosis is currently the most widely used desalination method globally. It's energy efficient and requires less space compared to thermal desalination. Advancements in membrane technology have further improved its efficiency and reduced costs in recent years. Thermal desalination, on the other hand, mimics the natural water cycle. Imagine boiling seawater and collecting the steam. As the steam cools, it condenses back into fresh water, leaving the salt behind. This method requires a lot of energy to heat the seawater, which can be a major drawback. There are different types of thermal desalination, such as multi-stage flash distillation and multiple effect distillation. While more energy-intensive, thermal desalination can be suitable for larger-scale operations and can utilize different energy sources, including waste heat from industrial processes. Section 5. The Energy Challenge. Desalination's thirst for power. Desalination, while a viable solution, is not without its challenges. As the global population continues to grow and climate change exacerbates water scarcity, desalination has become an increasingly important method for providing fresh water. However, the process is far from perfect, and comes with its own set of significant hurdles. One of the main concerns is its high energy consumption. Desalination plants require a substantial amount of power to convert seawater into potable water. This energy-intensive process can strain local power grids and increase operational costs, making it less accessible for regions already struggling with energy shortages. Both reverse osmosis and thermal desalination require significant amounts of energy to operate, contributing to greenhouse gas emissions if the energy source is not renewable. Reverse osmosis, which forces water through a semi-permeable membrane, and thermal desalination, which involves heating water to collect the steam, are both energy-hungry processes. This reliance on energy not only makes desalination expensive but also environmentally taxing if fossil fuels are used. Reducing the energy footprint of desalination is crucial for its long-term sustainability. Transitioning to renewable energy sources like solar and wind power can mitigate the environmental impact. By harnessing the power of the sun and wind, desalination plants can operate more sustainably, reducing their carbon footprint and making the process more eco-friendly. Researchers are constantly working on improving the energy efficiency of both methods. Innovations in technology and engineering are paving the way for more efficient desalination processes. Scientists are exploring advanced materials and techniques to make reverse osmosis membranes more effective and less energy intensive. This includes developing new membrane materials for reverse osmosis. These new materials aim to reduce the energy required to push water through the membranes, making the process more efficient and cost-effective. Enhanced membranes can also improve the lifespan and performance of desalination plants, further reducing operational costs. And exploring renewable energy sources like solar and wind power to power desalination plants. By integrating hybrid renewable energy systems, desalination plants can become more resilient and less dependent on traditional power sources. This not only helps in reducing greenhouse gas emissions, but also ensures a more stable and sustainable supply of fresh water for future generations. Section 6. Efficiency advancements, making desalination more sustainable. Scientists and engineers are constantly working to make desalination more efficient and sustainable. Advancements in membrane technology have significantly reduced the energy required for reverse osmosis. For instance, new membranes with improved selectivity can remove salt more effectively while using less pressure. In thermal desalination, innovations focus on utilizing waste heat from industrial processes or integrating renewable energy sources. For example, some plants now use solar thermal energy to heat the seawater, reducing reliance on fossil fuels and lowering their carbon footprint. Section 7. Brine disposal, the environmental price of freshwater. Another important consideration is the environmental impact of brine disposal. Brine, the highly salty byproduct of desalination, can harm marine life if not managed properly. Discharging concentrated brine back into the ocean can increase salinity levels, deplete oxygen, and disrupt delicate marine ecosystems. Finding sustainable solutions for brine management is crucial. Options include diluting the brine before discharge, using it for salt production or other industrial processes, or even exploring ways to extract valuable minerals from the brine itself. Section 8. Desalination's role: a solution but not a silver bullet. Desalination is not a magic solution to water scarcity. While it can provide a vital source of fresh water, especially in arid regions, it's crucial to recognize its limitations. The high energy requirements, environmental concerns, and cost implications need careful consideration. Rather than viewing desalination as a standalone solution, it should be part of a holistic approach to water management. This includes implementing water conservation measures, investing in water-efficient technologies, and promoting responsible water use practices across all sectors. Section 9. Looking ahead, sustainable desalination for a water-secure future. As the global demand for freshwater continues to rise, desalination will undoubtedly play an increasingly important role in meeting our water needs. With the world's population growing and climate change affecting traditional water sources, the pressure on freshwater supplies is immense. Desalination offers a viable solution by converting seawater into potable water, thus providing a reliable and consistent source of fresh water. However, the key to its long-term success lies in ensuring its sustainability. Traditional desalination methods can be energy-intensive and have significant environmental impacts, such as the discharge of highly concentrated brine back into the ocean, which can harm marine life. This means minimizing environmental impacts, reducing energy consumption, and making it an affordable option for all. By integrating renewable energy sources like solar and wind power, we can significantly cut down the carbon footprint of desalination plants. Additionally, advancements in eco-friendly water filtration systems can help in making the process more efficient and less harmful to the environment. Continued research and innovation are crucial for developing more energy-efficient desalination technologies, exploring alternative energy sources, and finding environmentally friendly solutions for brine management. Scientists and engineers are constantly working on new methods to improve the efficiency of desalination processes, such as using advanced membranes and energy recovery devices. Effective brine management is essential to prevent environmental degradation. Innovative solutions like brine concentration and mineral recovery can turn waste into valuable resources, further enhancing the sustainability of desalination. By embracing sustainable practices, we can harness the power of desalination to quench the thirst of a growing world. Communities around the globe can benefit from clean, reliable water sources, leading to improved health, economic growth, and overall quality of life. The future of water security lies in our ability to innovate and implement sustainable desalination technologies.